So in order to do so, we need to import a library called matplot. So let's go ahead and do that. Matplotlib. We need the pyplot within it, Python plot as plt, and then we run this. It takes some time. Perfect. Now the next step, what we want to do, right, is since we have some longitude and some latitude, we want to use those as main coordinates for the various points within our network, so that it's arranged according to where it is relatively in a particular map. So what we'll do here is that we'll basically draw it. First, before drawing the plot, we need to create a new variable within our node that's going to be called coordinate, and it's going to be basically a tuple that's made of the latitude and the longitude, and then we're going to use those positional values to kind of put the different points that represent our different airports within in the world. So in order to do so, we'll add a for loop right here for every airports in our connected network. Airports in network main, and then we need the nodes simply. We don't need the edges. Create a new variable that's called network. Where is it? Network main, I guess. Network, yeah, main. So main network, we're gonna grab the nodes. Node, not the node. No, we don't need the node. We actually do need the node. What am I talking about? Then in here, we're gonna put the airport ID, which is just the airport right there, and then we create a new coordinate, as I said, that's going to be called, yeah, let's call them coordinates. And that's going to be equal to a tuple that's made of the same thing. We're going to grab just these. I don't want to retype everything. Copy this, paste it right here, and then we need as well the same thing again right there. Maybe I'll even put it down here so it's more readable. I just need to know how I call it. Yeah, lat and long. We need these two variables, basically a tuple of these two. All right, so we need here, we're gonna put longitude and the latitude. Beautiful. Let's run this. Boom, ran perfectly. Now, basically, what's next? We need to draw it. So let's do it. So we use the nx.draw. nx.draw. Let's go ahead and draw the network main, I guess. Network main. Let's see, we'll add these nodes. nx.getNodes attribute, I believe. Yeah, attributes of what? Our network main. And then we'll need to grab the coordinates up in here. Coordinates right there. Now there are some other attributes we can add. We can add a shape. Let's put each airport as a dot. Node shape equals, let's see, let's add a dot. can add a dot up in here. There you go. And let's take the size of each of those things as node size. The size of each dot as, I don't know, 3 equals to 3. Let's run this. Oh, get attributes. What did I write here? Get attributes, not bts. What the attributes? Get attributes, and let's just show it. plt.show. This will show the map. The network, I guess. Give it some time to run. Boom, you got this. That's our first map generated. Not too bad, to be honest. At least you can see the shape of the different continents. They appear nice and clean. You can identify Africa here, North America, Europe, South America, Australia. It's pretty neat, to be honest. You got India up in here. Nice. It appears nice and not as clear as you want. Now we can modify it a little bit more so that it's a bit more visible. For the reason why it's so dark up in here is because the edges haven't been modified, so they have their default size, which is to 1, and it's kind of big compared to the node size. So we can really personalize each of those things. We can personalize the various node size, the width of the nodes. We can similarly personalize the edges, so the map doesn't contain too much information. So in order to do that, let's clear the plot and set a figure. So we can easily do it this way: plot dot figure, and then we can use as a figure size. Let's see, figure size. What size? 20 to 15. Let's put 20. Okay, let me turn that off. We can use as figure size. Let's see, 20 to 15. I think that should do it. 20 to 15, so that it creates a PNG that's rather large, not that small thing over here, but a larger figure. Now that's done. Let's go ahead and draw the network nodes. So it's pretty much the same. Instead of just writing draw and putting our attributes, we can actually write draw NetworkX. We add, let's say, for which one should we start? Let's start with the nodes. We'll first draw the nodes of our network, which is network main. Then we need to use the coordinates where we want them. So it's nx dot get node attributes of network main, and then we need the coordinates. Then we're gonna give it a width. Take a no, not the width. I mean a node size. Pretty much the same as the previous one. We'll use a dot. You can use a star. You can use whatever we want as a shape. You can even use a letter as a shape. So y'all can check out the different type of symbols online and just input it right there. But I think for our case, a dot does the job pretty well. Give it the node size of, I don't know, maybe since it's a larger figure, maybe we can leave it as what, 6, 7, node size 7, 6. Let's give it 6 and let's see whatever happens. 6, perfect. Then nx.draw, we're gonna draw the edges. Since most of it is similar, I'm gonna again risk the copy paste. Make sure this time I change the attributes properly. So draw NetworkX, place the nodes with edges, network main, That's correct. NX get net node attribute network main the coordinates. Yep. Now instead of the node shape, we need the width as attribute, width, and we are going to give it a 0.3, which is kind of fair, and then the alpha, which is, I believe, how the transparency and okay, I added an insert. Go remove these and set an alpha of, I think, 0.5 is a decent value. 0.5. Come on now. 0.5. Close the parenthesis. Now I can show the plot dot show, and let's run this. Give it some time. Beautiful. You have a larger figure compared. It's the exact same thing as this one, but it's a larger figure because we used the longitude, the different coordinates on a bigger board. So we used relatively the same node shape, and then we as well decreased the width of the different edges so that it just doesn't become like really dark. So you have now a clearer pictures of the different airports and everything. Now we can do something. We can go even further by assigning like colors to different edges, to different continents and everything, so that you have a better picture. It can apply to different kind of stuff within the graph. And for this case, we are going to put a color for the nodes in each continent. For example, we're going to make sure that the African airports are going to be green, the European one are going to be, let's say, red, the I would say the American one, I don't know, blue. So for each airport, then we're going to double check, let's say, what routes do certain airlines take. For example, we're going to put a red color for the routes that the Turkish airline takes. I think I believe their code is TK. We're going to do the same for the US airlines. Yeah, we're going to put blue as all the routes that US airlines takes. Lastly, we're going to take into consideration the centrality as well, which is the importance of the different airports. So basically, the airports that receive the most traffic will have larger nodes. So in this graph, you can see that the different nodes have this exact same size, but in our final graph, the airports that have the most degrees, that receive the most traffic, will be bigger than the other ones. So three things will happen. We are going to assign color for nodes in each continent, different color for each continent. Then we're going to assign a color for the routes that certain airline takes, notably Turkish airline and the US airline. And then we're going to use the centrality to assign bigger nodes to airports that receive the most traffic and smaller ones to the ones that do not. So let's go ahead and start. First, we need to get the different centrality values. So let's see. So the maximum centrality, let's define, let's see, maximum centrality. Maximum centrality. So I think I did calculate the centrality earlier in the tutorial. It's gonna be maximum. Let's see, how did I call it? I think it should be somewhere up here. Don't remember exactly the name. Okay, next connected component, not that. Let's see, centrality. I did do it somewhere here. Let's see. Edges, disconnected, path, network subgraph. I really don't. Ah, here it is. is degree centrality. All right, it's gonna be the maximum of this. We need to save it somewhere. Max degree centrality. Then we're gonna need just the values. We don't really need something else. Values. Make sure you add the parentheses. Now first, as I said, we need to assign a color for each continent. So for let's say airports in network main, so if basically of if conditions. Now if network main dot nodes is equal to airport, let's use, I think, the time zone. Let's see how the data looks like real quick. So we can use the time zone Europe, time zone, okay, America, we got Asia. Let's see, time zone, we'll use this format. Alrighty, so back to it. So we're going to use the time zones, as I said. Let's go ahead and write it down here. Time zone. We're going to need to find, let's say, Europe within the time zone, because the continent is written there, equals to 0. Equals to true. Come on now. Then the network main dot nodes of that particular airport let's add the color in. Color is going to be equal to, what's the European color? Blue? It's not a blue, yeah, blue. Now we are going to do the same for every single one continent. So it's basically this. Yes, we need to copy. Then we add here an elif. Do the same time zone. What is the next continent? I'll guess Asia. I need to remove the insert. Asia is equal to 0. Then we're going to give it a read. Let's go elif. Go for Africa. You're gonna give it a yellow. Keep on going. elif. We have Africa now. We are going to take, let's see, America. What color should we give them? Blue, green. Let's give it green. And what else? I think there is the Australia. If I'm not mistaken, let me double check to be sure. Yeah, it's their own continent in this data set. Yeah, it's their own continent. Australia, we give Australia orange. And the Pacific Islands finally. If Pacific, Australia, Pacific, I think we give it a purple. Purple. Else if the continent doesn't appear, we can simply where is it, network main dot nodes. Okay, I have a bracket missing here. Okay, nodes airport, and the color, let's keep it color, gonna give it a gray color, equals gray. Good. Now we need to set the size of the different nodes based on the essentiality. Let's give it some space. So let's say if let's pick again our network ports, and then we need essentiality here of, how did I call it when I saved it? It's right here, degree essentiality. Let's copy this real quick just to make sure we get the names right. Instead of colors, change it to degree essentiality. Is above, let's say, max essentiality, maximum essentiality. So we need the one that contain more than 90% of the values. Max essentiality times, let's see, yeah, is above or equal to max essentiality times .9, so it contains 90% of the traffic. Let's see, not sure if there is an airport like that, but we don't know. All right, we add again these, lot of copying, airport, network. Then we need to set it as, let's see, what can I use it for? Let's call it as, are they weights? Centrality to measure the importance. Let's put, yeah, let's put importance. The importance as put a deliberate number, let's say 400. That's basically just gonna be how big this node is gonna be. Now we're going to use the same exact principle for the 50% of the traffic ones. Let's see, elif the degree centrality is above, let's say 0.5%, we go use as importance of 200. Else, okay, that's too much, let's just put 150. Else the rest will have an importance of let's see, no, I actually just need this. Else we'll have just small nodes. Else let's put it as, what's a good number, maybe 10. Yeah, why not 10? So now that we're done putting parameters on our nodes, we need to do the same for, let's see, blue equals to blue. Where is it at? Color. Okay, what is this now? What is wrong now? Ah, I forgot to close the bracket. Yeah, now that we are done with oh, it's all of them. Okay, this is good. I forgot to close it here. Okay, good. Here, then we should be good. What is the problem? Subgraph airport is not callable. In here I forgot the nodes. You need the nodes in because that's what we're using. We're working with the nodes. .nodes. So now it's perfect. Everything is good. Now that we're done working with the nodes, now we need to assign colors for the different edges. As I said, we want to double check the routes of the Turkish Airlines and the routes of the American Airlines, and the rest we'll just keep it as standard routes. We'll keep them gray. So let's go ahead and compute that. So for every for let's say routes in network main.route, not nodes, we need the edges here. Perfect. We need to grab, so if let's say network main, let's open up the different edges. So you need a route route 0, network main, route 0 again. Yeah, same, route 1. We need to grab, for each edge we need to grab, let's see, the airlines, which is air lines, and as I said, we need Turkish airline is equal to TK in like that. So if that happens, what needs to happen, we need to assign a color. Let's see, we need the exact same thing here. I don't feel like rewriting everything. Let me make sure everything is good. Yeah, everything is good. All right, copy this, and then we grab the color. It's gonna be equal to, so let's give it a read, and then we grab again everything, the same thing here. I think I've already copied it. Yeah, we need to, let's add in the size of the edge. We'll give it a bigger size than normal. Let's see, 1.5, just for us to recognize the routes. Let's run the exact same thing as we did here on the else if, paste this in. Now we need the US airlines, and then we're going to assign this as a blue color. We can keep the same weight. Else, let's see, NetworkX dot route 1, route 2. Let's just keep this size and color. Let's grab these, and then we're going to set them as gray. Let's see, a gray color, I think, for the routes, just to have the same color as the one on top, gray color. And then a smaller size than the other ones. Let's see, 0.1, I guess. I think 0.1 should do. 0.1 will be good. Or I can get a bit bigger size. Let's see, 0.4. Let's keep it 0.2 then. That's good. Good. So we did everything that we needed to do. We assigned the size of each node based on how their importance. We assigned each continent the color. We assigned the roots of Turkish airline a color, the roots of the US airline color, and the remaining roots will have just a gray color. Now we need to run this and plot it. Let's run this. Else I forgot these. What's the problem now? Let's see, airlines. Isn't it how it's written? Oh, or there isn't there? Let's see. Maybe it's that airline. Let's run this. Perfect. Perfect. Now let's do the same as here. Let's plot everything. Can use kind of the same plot figure right here. Grab these. Plot figure. Let's go ahead and draw it. We kind of need pretty much the same thing. Let's go grab the nodes up in here. Paste it in. So for network main, we grab the coordinates. The shape will be a dot. The node size. So we already set the node size up in as an attribute, so we just need to grab the node size in our network. We can just use a list comprehension for that. So we need for the value, let's just keep v. For let's actually size. For size in nx dot get node. I guess it's not, I didn't call it size. I guess I called it importance. For the importance of each node and importance and get node attributes of our network main. All right, for our network main. When what do we need to grab in network main? We need to grab the importance, so that is a string, and add importance, and we just need to add, since it's a dictionary, we need to add values and close the parenthesis, add a comma, go to the next line. Then the last thing we need is the color, so we can write node color. That's going to be equal the same thing. We need list comprehension. We can just copy this. Don't feel like rewriting these, and just change this as color, so that we color in NetworkX dot get node attributes. Network main, we need the color here. Color. Grab the values, and then we go close down everything. So we need to where is the closing? Must have made a mistake somewhere, because we're supposed to be able to close this. How do I close that? Where's the, it's right here. So there is something missing here. No, that doesn't, this is not supposed to be there. Okay, perfect. Now that we are done with the nodes, let's go ahead and draw the edges. We got the node shape, node size, node color. Perfect. Now let's go ahead and grab this for the edges. We can just copy this and similarly paste it right here and extrude we need the coordinates, get edges. The edges have a width. We can use list comprehension right there, and for the width the alpha is going to be the same, 0.5. actually we can even decrease it to 0.1. the width is going to be equal to, let's just grab these since they're kind of similar. Remove this, paste it right there. So we need to grab how did I call it, where's the edge? We need to grab the size for size, for size, in NX and then we grab size here. Value is good. And now we need the colors. Where is it? Down one line. Can simply grab this again, copy, paste, change the width to edge color. Good. Now for color, simply color. Another mistake that I just realized that I did, color, and here get node attribute. Now it's not node, it's edge. Get edge attribute. Same here, get edge attribute. Attributes, network main, we need the color and not the size. Color dot values. And I think we're about done. Let's go ahead and plot it. plt dot show. Let's run this. Invalid alpha equals to 0.1. Why is it invalid? Let's see. I didn't put a comma after this. Perfect. I think it's creating the plot. And there you have it. There you have it. You have all the routes of a Turkish airline that are in red right there. You have this different centralities and everything. Here's the routes of the US airlines throughout the world. But there is something missing. The color of the continents weren't picked up properly. Let's see. Let's figure out why real quick. And I realized why. That's a terrible, terrible mistake that I made right here. None of the nodes were picked up because I forgot the S right here. See? So to fix this, I can just remove this. Let's run this again. Oh, let's plot the figure again. Hopefully it's gonna be good this time. Perfect. Now everything has been picked up. Here's the final result. So I have the African continent in yellow. Yellow wasn't a very good color, I guess you can't see it properly. that you can see, and there's various way you can transform the data to get some piece of information that you didn't know about this way. So really, NetworkX is a very, very good tool. And if you reach this part of the video, please just leave a like, show me that y'all are here. If you want to see more of these tutorials, just subscribe. I'm gonna be posting way more often. And yeah, the code that I use will be available in a text-based version of this tutorial in our website. I'll leave a link down in the description below. I'll leave a link as well to the Open Flights database, to the NetworkX as well documentation, so you guys can have more tutorials down there and check out the different tools they have, so that you can use in your various projects. Once again, thank you guys for watching, and I'll see you in the next video. Bye.